Friends, my warmest greetings to all of you. I am Ramanath Kausik, Professor of Physics and Director, McDonald Center for the Space Sciences of Washington University in St. Louis. It is a great pleasure and an honor to introduce the world-renowned physicist, Professor Jogesh Pati of Stanford University in America. He has kindly agreed to lead the interview that you are about to watch. This pertains to the Indian Neutrino Observatory planned in Tamil Nadu in the Theni district, and it will be soon constructed when everything goes well. Professor Pati has made pioneering contributions to particle physics by initiating the idea of grand unification of fundamental particles and their forces. His formulation of grand unification, in collaboration with Nobel laureate Abdus Salam, led to some far-reaching predictions, including the possibility of proton decay and other exotic processes. Pati-Salam model provides the crucial ingredients for understanding the ultralight masses of the neutrinos, whose measurement is one of the main goals of INO. Professor Pati has won several honors and awards. In particular, he was awarded the prestigious Dirac Medal for his seminal contributions to quest for unification. He was also conferred the Padma Bhushan title by the President of India. I request Professor Pati to introduce the theme of INO program. Professor Pati.
Dear friends, my heartiest greetings to all of you. On behalf of a large number of scientists of Indian origin living in India and abroad, I have the pleasure of introducing you to the theme of this interview program, which you are about to watch. The program is designed to tell you what the Theni Neutrino Laboratory, called INO, is all about. INO stands for India-based Neutrino Observatory. This laboratory is being built in Tamil Nadu, India. At present, it is awaiting clearance from the authorities so that it may complete the construction that remains and proceed to make advancement in science. Simultaneously, it aims to bring long-term benefits to India as a whole, in particular to Tamil Nadu and the Theni district, by promoting not only science and science training, but also growth in technology and local economy. What is INO? It's an entirely India-made underground laboratory. In the beginning, it aims to study some fundamental properties of one of the most interesting elementary particles, called neutrinos. Well, what are neutrinos and why are they so interesting? I will mention two reasons for the latter. First, neutrinos are very small microscopic particles like the electrons as regards their sizes. But unlike electrons, the neutrinos carry no charge, almost no mass, and hardly interact at all. In fact, they exist all around us, within us, and pass through us. About 1 trillion neutrinos emitted by the sun are passing through you and me every second, all our life, but we don't see them and we don't feel them. This is why they're called the ghost particles, but of a friendly kind. They cause no harm because they hardly interact at all. Second, they are not only friendly, but they are in fact essential for our existence in the following sense. It turns out that if there are no neutrinos, the mechanism for the sun to produce light and heat will simply stop, and life as we know won't exist. Thus, the neutrinos are crucial to our very existence. In this sense, they are the friendliest particles we have with us thanks to nature. These are some of the reasons why the neutrinos are special and most interesting. Now, who are the speakers? The program is fortunate to have some of the most distinguished scientists of the world as speakers. They will be introduced properly very soon. For now, I'll mention only briefly about them to note that each of them is specially qualified to tell us about some relevant aspects of the Tenney Neutrino Laboratory, that is the INO. They include, first, Professor Takaaki Kajita, Director of the Institute of Cosmic Ray Research in Tokyo, Japan. Second, Professor Arthur MacDonald, Director of Sudbury Neutrino Observatory, Canada. Now, both Professor Kajita and Professor MacDonald won the Nobel Prize in Physics in the year 2015 for their groundbreaking discoveries of neutrino oscillations of two different kinds. Both showed that the neutrinos do have mass, though tiny. And third, Professor Francis Helson of the University of Wisconsin, Madison, USA. Winner of several major awards, Professor Helson is the principal investigator of the IceCube Neutrino Observatory, which is located more than a mile under the ice at the South Pole. Next, we will have Professor Rohini Godbole of the Center of High Energy Physics, Indian Institute of Science, Bangalore, India. She is a distinguished theoretical physicist with many awards. Now, being based in India, she is specially qualified to tell us about the impact of INO on the growth of Indian science and science training of the PhD students of India, as well as about its benefits to the promotions of technology and the local economy in Tamil Nadu and the Tenney district. Next, we will have Dr. Balachandran, a well-known geologist, now retired after serving for 36 years as the Deputy Director General of the Geological Survey of India. He will tell us whether there will be any adverse geological impact owing to the construction of INO on the neighboring area of the Tenney district. Finally, we will have Professor Ramanath Kausik, Director of the James McDonnell Center for the Space Sciences at the University of Washington, St. Louis, USA. He has made many original contributions, some pertaining in fact to neutrino masses, and is regarded by many as the father of astroparticle physics. He has won several awards. He will summarize the talks of the different speakers and will emphasize the benefits of INO to India and Tamil Nadu, based on his own direct experience. At this point, I should add that none of the speakers listed above, and neither Professor Subir Sarkar, who will interview some of the speakers, nor I, have any direct connections with the INO. Before closing, let me mention the kind of questions which the speakers will address. These include, are neutrinos safe? Would INO be safe to the environment and the people? Second, what would be the special benefits of INO for India, the state of Tamil Nadu, and the Tenney district in particular? And third, how would INO benefit world science? In addition, we'll hear from the students and some of the other speakers how is INO benefiting the science training of its PhD students now, and assuming that it will be revived soon, how valuable would it be to the students 5 to 10 years from now, when the prospect for making a major discovery on neutrino masses will be looming large in the horizon. These questions are clearly relevant to the people and the leaders of Tamil Nadu and of Tenney. At this point, let me make a comment of my own. The INO would be valuable not just to study some important aspects of neutrino masses, but it would continue to provide long-term benefits for decades to come. This is like having the facility right in your backyard, in your own country, and that would transform Indian science. I would thus urge all of you to listen to the voices of the speakers in the program and then judge for yourselves whether INO do all good but no harm, and if so, should it be revived at its present site with no further delay. Thank you. I will now like to hand over the program to Professor Subir Sarkar, who will introduce the speakers and conduct the interviews of 3 sessions. Before doing so, let me say a few words about Professor Sarkar himself. Professor Sarkar is a distinguished physicist holding 2 top positions. He is the head of particle theory at the University of Oxford, UK, and the Niels Bohr Professor at the world-famous Niels Bohr Institute in Copenhagen, Denmark. On the one hand, he is a theoretical physicist of international repute, working extensively in the field of astroparticle physics. On the other hand, he also participates in leading experiments such as those being carried out at the IceCube Neutrino Observatory at the South Pole. He won the IUPAC Homi Bhabha Medal in 2017. With these words, I would like to hand over the program to Professor Sarkar. Professor Sarkar.
I'm Subir Sarkar. I'm Professor of Physics at the University of Oxford. It is an honor to introduce Professor Taki Kajita, Director of the Institute for Cosmic Radiation Research at the University of Tokyo. In 2015, he shared the Nobel Prize for Physics for the discovery of neutrino oscillations, which shows that neutrinos have mass. This research was carried out at Super Kamiokande, a neutrino observatory located 1 kilometer under Mount Ikeno in the Mozumi mine near the city of Ida in Japan, which has been operating since 1996. It succeeded the Kamiokande experiment at the same site, which began in 1983 and earned the Nobel Prize in Physics in 2002 for the observation of cosmic neutrinos for Masatoshi Koshiba, who was Professor Kajita's former mentor. With this experience, Professor Kajita is very well qualified to comment on the India-based Neutrino Observatory, INO. I will therefore ask him 3 questions to which many people in India would like to know the answers from a world-leading expert like himself. First, Professor Kajita, can you please tell us in a few words about the scientific merit and benefits from INO for science in the world?
Thank you for asking. Many scientists think that neutrino physics is very important for the better understanding of elementary particles and the universe. The INO detector is a unique and advanced neutrino detector. The world neutrino community will really benefit by the data from INO.
Thank you. Secondly, fears have been expressed about the possible harm caused by neutrinos and the INO detector to the environment near the INO site. In your view, what, if any, are the hazards from the atmospheric neutrinos being studied at Super Kamiokande and planned to be studied at INO?
Well, neutrinos are the most difficult particles to observe. Most of them pass through everything, including neutrino detectors. Therefore, to detect neutrinos, we need a very large detector, such as Super Kamiokande. We observe very rare neutrino interactions with these advanced neutrino detectors. There is no doubt that the existence of these detectors will not cause any harm or hazard.
Thank you. Finally, based on your direct experience, can you please comment on the benefits which INO would provide for the growth of science and education in the state of Tamil Nadu and in India as a whole?
Well, INO will clearly be a unique neutrino detector. INO will contribute to the basic science in the world, or more explicitly, the data from INO will largely contribute to our understanding of neutrinos, elementary particles, and the universe. In addition, the existence of world top-level experiments such as INO is very important for training the students. Students learn the cutting-edge technology and are exposed to the world community of scientists. Therefore, the students in Tamil Nadu and in India should benefit a lot with the INO experiment.
Thank you. It is an honor to introduce Professor Arthur MacDonald, who is director of the Sudbury Neutrino Observatory in Canada and emeritus professor at Queen's University in Kingston, Ontario. In 2015, he shared the Nobel Prize for Physics for the discovery of neutrino oscillations, which shows that neutrinos have mass. This research was carried out at SNO, a neutrino observatory located over 2 kilometers underground in a nickel mine in Sudbury, Canada, which operated from 1999 to 2006. Subsequently, the underground laboratory has been enlarged into the Snow Lab facility and also hosts several other experiments which are searching for dark matter and neutrino mass. In 2016, Professor MacDonald was awarded the Breakthrough Prize in Fundamental Physics. With this experience, he is very well qualified to comment on the proposed India-based Neutrino Observatory, INO. I will therefore ask him 3 questions to which many people in India would like to know the answers from a world-leading expert like himself. Can you please tell us in a few words about the scientific merit and benefits from INO for science in the world?
Based on the measurements that we have made, we know that neutrinos do have a finite mass. Neutrinos, along with electrons and quarks, are the basic building blocks of nature that we do not know how to subdivide any further at this point in time. But neutrinos are difficult to detect, and therefore their properties are not fully known. We would like to know in particular, with the specific capabilities of the INO detector, what the ordering of the 3 masses is between the neutrinos. This is something that the Indian scientific community can contribute to the world. It's a basic understanding at the most fundamental level that we are very much hoping that the Indian science community with INO will be able to provide.
Thank you. Secondly, fears have been expressed about the possible harm caused by neutrinos and the INO detector to the environment near the INO site. In your view, what, if any, are the hazards from the atmospheric neutrinos planned to be studied at INO?
Humans have looked up at the skies forever. As they became more progressive, they were able to use telescopes to look at the light coming from the heavens in more detail, to understand the stars, and to develop models for how our universe has evolved. The INO is a telescope, similar to the telescopes used to study light. It's a telescope that studies neutrinos, and it is placed underground because this is the most favorable location to observe these difficult-to-detect particles. But neutrinos themselves are a part of what comes to us from outer space. In fact, they are completely benign. They have no effect on human beings, and yet, if we can understand their properties in the ways that INO can help us to do, we can understand how our universe has evolved, because neutrinos have played a large role in that over the process of evolution of the universe.
Thank you. Finally, based on your direct experience, can you please comment on the benefits which INO would provide for the growth of science and education in the state of Tamil Nadu and in India as a whole?
Well, in particular, I am in Sudbury today. And Sudbury was an industrial community in Canada to which SNO and now SNO Lab have been added. It creates a scientific basis, and Sudbury is now known around the world for having done the most fundamental science. In terms of educating young people, we have educated hundreds of young people and are having the ability to do even more than that, because we have the world coming to Sudbury to collaborate with us on these experiments. Because if you are able to go underground, as you will with the INO, you are doing unique things. For your local scientists, for your local students, you'll be training people in the technology at the cutting edge of technology in order to accomplish this work. This creates people who are capable of going on to lead your scientific effort in universities, but it also creates people who are technically literate, can work in your industries, and can influence your future development of your country. That has been the case in Canada, and I'm sure it would be similarly the case in India.
Thank you. It is an honor to introduce Francis Halzen, who is professor at the University of Wisconsin-Madison in the USA and principal investigator of the IceCube Neutrino Observatory in the Antarctic. Construction of this kilometer-sized experiment deep in the ice cap under the South Pole began in 2004, and in 2013 it made the first observation of high-energy cosmic neutrinos. IceCube has also made precision observations of neutrinos produced by cosmic ray interactions in the Earth's atmosphere, unveiling their fundamental properties. For this groundbreaking work, Professor Halzen has received many awards, including the European Physical Society Prize and the Bolzan Prize in 2015. Professor Halzen is thus very well qualified to comment on the proposed India-based Neutrino Observatory, INO. I will ask him 3 questions to which many people would like to know the answers from a world-leading expert like himself. Hello, Professor Halzen. First, can you tell us briefly about the scientific merits and benefits from INO for science in the world?
So all matter is made of protons and neutrons, and these make up nuclei, and then with electrons these nuclei form atoms. But there are also neutrinos. Neutrinos are in fact the most common of these particles I have mentioned that make up the matter. Neutrinos switch neutrons into protons, and without them the sun would not shine, and the air we breathe would not have formed in stars. They are part of nature, like birds and trees. One major difference, we cannot see them. To look at them, we need special glasses, and that is INO. It is a camera that allows us to look at the neutrinos that are present in nature and study them. Our knowledge of neutrinos help us to understand our universe, and from the present day back to the very beginning. So INO will contribute to answering the most fundamental questions that we can ask about our very origins and those of the universe that we live in.
Thank you. Secondly, fears have been expressed about the possible harm caused by neutrinos and the INO detector to the environment near the INO site. In your view, what, if any, are the hazards from atmospheric neutrinos being studied at IceCube and planned to be studied at INO?
Neutrinos cannot do harm. They are already present in nature anyway, and clearly do not harm us. It is important to realize that neutrinos are always passing through us at nearly the speed of light. They do not touch us. They just go through us unaware of our presence, just as we are unaware of their presence. I am the principal investigator of a project called IceCube, as you heard in the introduction. It turned natural Antarctic ice into neutrino glasses at one of the most environmentally protected places on Earth, the South Pole. In fact, IceCube and INO do pretty much the same science using similar techniques.
Thank you. And finally, based on your experience, can you please comment on benefits which INO may provide for the growth of science and education in the state of Tamil Nadu and in India as a whole?
I hope that my previous answers reflect the deep questions that are associated with the observation of neutrinos. By looking at neutrinos, INO sees the universe. This will inspire students of all ages in the state of Tamil Nadu and more widely in India, just as it does at several experiments elsewhere on Earth. Progress in understanding the physics of neutrinos has generated many Nobel Prizes already. INO provides the extraordinary opportunity to bring state-of-the-art scientific technology and computing to your area without the adverse environmental impact that is often associated with such developments.
Thank you. It is a pleasure to introduce Professor Rohini Godbole from the Center for High Energy Physics at the Indian Institute of Science in Bangalore. She is an internationally renowned particle theorist and Vice President of the National Academy of Sciences in India. In 2009, she was awarded the Satyendranath Bose Medal of the Indian National Science Academy, and in 2015, the Devi Award of the Indian Express Group. She is also well known as a science communicator and champion of women pursuing careers in science and technology. Professor Godbole is thus well qualified to comment on the proposed India-based Neutrino Observatory, INO. I would like to ask for her view of the benefits which INO would provide for the growth of science and education in the state of Tamil Nadu and in India as a whole.
INO will see neutrinos and antineutrinos which are continuously streaming through the Earth from all sides. Due to some unique features of the plant detector, it will have ability to answer questions at the next frontier to be conquered in particle physics after the spectacular discovery of the Higgs boson at the Large Hadron Collider. Indeed, INO's results will contribute to important advances in our knowledge of the laws of nature and of the universe.
Thank you. Secondly, fears have been expressed about the possible harm caused by neutrinos and the INO detector to the environment near the INO site. In your view, what, if any, are the hazards from atmospheric neutrinos?
Neutrino experiments like INO are completely benign because one is just tapping the neutrinos that are passing through us all the time. So this is a completely passive and hence harmless exercise. The scientists are just using the naturally existing neutrinos and nothing more.
Thank you. And finally, based on your experience, can you please comment on benefits which INO may provide for the growth of science and education in the state of Tamil Nadu and in India as a whole?
The importance of a mega science project in our own country cannot be overemphasized. Not only it will create knowledge at the forefront of our quest of understanding the secrets of nature, but it will also train young students and engineers in the cutting-edge technology to become the next generation of scientists and engineers. No country can progress without developing the expertise in technology and innovate therein. INO will offer immense opportunities to Indian industry and train it to make in India the components needed for the future detectors in particle physics in the world. In the early days of preparatory work, the INO experimenters have already trained a generation of students who at present are working at other big neutrino experiments in the world, biding their time till they can come back and contribute to INO as soon as it starts. In fact, China has embarked upon other mega science projects and is successfully completing them at a fast rate. Being on an advisory committee of one such international project, I have seen myself the impact it has had on their human resource development. Indian theoretical physicists as well as experimental high energy physicists working at Geneva have put Indian particle physics on the international map. Now with INO, Indian particle physics will be taking the next step in executing an Indian and yet international program in India. Needless to say that mega projects like this can only benefit the local industrial economic development. the 1500 crore rupees to be spent on INO will not only bring a boost to the industry in any district, but will in fact bring overall increased employment and development. INO could bring the same benefits to any district as the CERN laboratory did to Geneva in Switzerland. To summarize, we see that not only INO will do no harm, it will be to the good of Tamil Nadu and Theni district in particular. Hence, sooner the roadblock facing INO is removed, the better it would be for India, for Tamil Nadu and for Theni district.
Having now heard from several distinguished physicists from across the world, I would like to invite Professor Ramnath Kaushik to summarize and reflect on what they have said. Ramnath Kaushik is the James McDonnell Professor of Space Sciences at Washington University in St. Louis, USA. He started his research career at TIFR Mumbai in 1961 and worked for 40 years in space science, cosmic rays, and fundamental physics, eventually becoming distinguished professor. He then became director of the Indian Institute of Astrophysics at Bangalore, where he led an ambitious project to set up an astronomical observatory in Hanle, Ladakh. Kaushik is internationally renowned for having made seminal contributions to the subject of neutrino cosmology and for having pioneered the field that is now called astroparticle physics. He has received numerous awards, among them the Vikram Sarabhai Award, the Shanti Sarup Bhatnagar Prize, the Vainu Bappu Medal, and the Padma Shri of the Government of India.
On behalf of the people of Tamil Nadu and indeed of all the people in India, Professor Subir Sarkar of Oxford University, a well-known theoretical physicist, has posed three important questions to the four scientists of great achievement. What is INO and what are its scientific objectives? Does this detector and the neutrinos cause any harm to the people or the environment? What are the benefits to the people of Tamil Nadu and others? All the four distinguished scientists have spoken, and now I will summarize their remarks. The neutrino telescope is a huge electronics camera that will be built to photograph the neutrinos. Thousands of crores of these neutrinos are flying around everywhere, and they cannot be seen and felt by us. However, by photographing them, the scientists will find out how the whole universe came into existence and the properties of the tiniest building blocks of matter. This knowledge will be shared with everyone for the advancement of science and of mankind. In fact, this kind of research started in India in 1950 at the Kola gold fields. The very first natural neutrino was observed by the Indian scientists in the year 1965, stimulating great excitement. Is there any harm or danger due to this? None at all. Scientists would like to study these particles that are already present in the environment, created in the atmosphere or emitted by the sun. This ever-present neutrino background has caused no harm over millions of years and never will in the future, either to man or to the environment. That is why, even at the South Pole, the most protected and pristine of all places, they allowed a similar instrument to be built. What are the benefits to the people of Tamil Nadu and to others? This is a very important question. The people need to know, and our leaders are asking the same question. There are three benefits. The neutrino observatory is like an advanced university. A large number of students will get trained in the latest fields of science and technology. It will be a center for excellent education. There will be tremendous economic benefit from such a major instrument. And the investment involved in building those instruments are huge. Moreover, it will stimulate the growth of local industry on a broad set of fronts: engineering, electronics, computer science, etc. And by ripple effect, it will create a large number of jobs. Equally importantly, TENI will attract national and international attention with all the attendant benefits. I can say this from my personal experience. When I was the director of the Kodaikanal and Kavalur observatories, I was asked to build a very large telescope in the distant part of Ladakh in the Himalaya mountains. Within a few years, the region of Hanle and indeed all of Ladakh experienced unprecedented growth and prosperity. I am therefore sure that the Neutrino project will immensely benefit TENI and Tamil Nadu. Thank you all.
Till now, we have heard the opinions of a number of scientists, eminent physicists who are from India and abroad, none of whom were connected with India-based neutrino observatory. Their views and opinions, I am sure, would have dispelled many of our fears, answered some of our questions, and also made it clear that how this project can bring economic and educational benefits to India and Tamil Nadu. Now, let's hear the view of Mr. V. Balachandran, who had more than 3 decades of experience with Geological Survey of India, and he was also the member of Dam Safety Committee of Tamil Nadu and also the combined Andhra Pradesh and Telangana earlier. He has built a number of dams, caverns underneath it, tunnel underneath it. He has huge and rich experience in constructing tunnels in particularly Western Ghats. We will ask him what kind of impact, if any, this project, pre-construction and post-construction, can have on environment, the hills and the region.
வணக்கம். இன்றைக்கு நியூட்ரினோ அச்சங்களும் அறிவியலும் என்ற தலைப்பில் ஒரு சில விஷயங்களை உங்களோட பகிர்ந்து கொள்ள போகிறோம். குறிப்பாக புவியியல் சார்ந்த அச்சங்கள், கவலைகள், கேள்விகள் போன்ற விஷயங்களை உங்களோட பகிர்ந்து கொள்ள போகிறோம். நம்மோட இந்த நிகழ்ச்சியில் பங்கெடுக்க வந்திருப்பவர் டாக்டர் வி பாலச்சந்திரன். அவர் டெபுட்டி டைரக்டர் ஜெனரல் ஆஃப் ஜியோலாஜிக்கல் சர்வே ஆஃப் இந்தியா அப்படிங்கிற நிறுவனத்தில் 36 வருடங்கள் பணி செஞ்சுருக்கிறாரு. ஒரு மலைக்கு கீழே 2 கிலோமீட்டர் அளவுக்கு தோண்டணும், சுரங்கம் தோண்டணும். ஸோ நீங்கள் அந்த 2 கிலோமீட்டர் அளவுக்கு நீங்கள் மலையிலேருந்து அப்படியே மேலேருந்து தோண்டிட்டு வந்தீங்கன்னா கிணறு மாதிரி ஆகிடும் இல்லையா? அப்போ பக்கத்தில் இருக்கிற தண்ணியெல்லாம் உள்ளே போயிடுமே.
மேலேருந்து கீழே சுரங்கம் தோண்டல, ஒரு சைடுல இருந்து நாங்க இந்த மலை உச்சியினுடைய நேர்கீழே சென்றடை. ரயில்வே டனலோ இல்லை ரோட் டனலோ அந்த மாதிரி ஒரு டனல் இது அந்த சுரங்கத்தை அடைவதற்கான ஒரு வழி.
பட் இப்படி தோண்டும் போது அந்த திட்டத்தில் என்ன சொல்லியிருக்காங்கன்னா சுமார் 450 டன் வெடி மருந்தை பயன்படுத்த போறோம் அப்படின்னு சொல்லியிருக்காங்க.
இந்த திட்டம் கிட்டத்தட்ட 3-4 வருஷம் நடக்கும். ஒவ்வொரு நாளும் நம்ம எவ்வளோ எக்ஸ்கவேட் பண்ணுறோங்கிறத பார்த்தீங்கன்னா, நம்ம ஒரு ஹோல், ஒரு துளை ஒன்று இட்டு ஒரு அப்ராக்சிமேட்லி ஒரு ஹோலுக்கு ஒரு 5 கிலோன்னு வச்சுக்கிட்டிங்கன்னா இட் வில் பி அபவுட் 100 கிலோஸ்.
எவ்வளோ தடவை அந்த மாதிரி பண்ணுவாங்க?
ஒரு நாளைக்கு பிளாஸ்ட்டுங்கிறது 2 தரம் இல்லை 3 தரம் பண்ணுவாங்க. இந்த பிளாஸ்ட்டுங்கிறது இட்ஸ் மில்லி செகண்ட் பிளாஸ்ட், அதாவது ஒரு செகண்டுக்கு கீழே இருக்கிற பிளாஸ்ட்.
அதாவது ஒரு நாள்ல 3 நொடி
3
தனித்தனி
நொடியா வச்சு
அதுலேருந்து வர அதிர்வுல பக்கத்துல 2 கிலோமீட்டர்ல தான் டி புதுக்கோட்டை ஊர் இருக்கு,
வில்லேஜ் இருக்குது.
அந்த வில்லேஜில் இருக்கக்கூடிய வீடெல்லாம் இடிஞ்சு வந்துரும்ல?
இல்லை, நிச்சயமா இடியாது. இந்த பிளாஸ்டினுடைய அதிர்வுகள் அதிகபட்சமா 200 இல்லை 300 மீட்டர், மேக்சிமம் 500 மீட்டர் போகலாம், அவ்வளோதான். அதுவும் முதல்ல இருக்கிற ஸ்டேஜில் போகும். நீங்க சுரங்கத்துக்கு உள்ள போயிட்டீங்கன்னா அது இன்னும் குறைஞ்சிட்டே வரும்.
ஸோ வாயில தாண்டி கூட வராது. ரெண்டாவது முல்லை பெரியாறு அணையோடையோ இல்லைன்னா இடுக்கி நீர்த்தேக்கத்துடையோ இதை சம்மந்தப்படுத்தி பேசி இந்த பிளாஸ்டினால அந்த அணைகளோ
இல்லை நீர்த்தேக்கங்களோ பாதிப்படையுங்கிறது வந்து ரொம்ப தவறான கருத்து.
ஏன் அப்படி தவறுன்னு நினைக்கிறீங்க?
அந்த தவறுன்னு நினைக்கிறதுக்கு காரணம் என்னன்னா, முல்லைப்பெரியாறு அணை கட்டின விட்டு முல்லைப்பெரியாருக்கு கீழே ஒரு சுரங்கம் போட்டு.
முல்லைப்பெரியாறு எப்போ கட்டினாங்க?
முல்லைப்பெரியாறு 1895 கட்டினாங்க.
1895.
1953லேருந்து 57 வரைக்கும் லோயர் பெரியார் ஹைட்ரோஎலக்ட்ரிக் பெரியார் லோயர் ஹைடல் ப்ராஜெக்ட்னு ஒன்று தமிழ்நாட்டில் ஒன்று கட்டினாங்க. அதுக்கு ஒரு சுரங்கம் போட்டிருக்கிறாங்க. அந்த சுரங்கம் முல்லைப்பெரியார் அணை கட்டி அதில் நீர் தேக்கின பின்னாடி அதுக்கப்புறம் போட்ட சுரங்கம் அது. அதே மாதிரி இடுக்கிலையும் அவங்க வந்து 1973 1974 அதை கன்ஸ்ட்ரக்ட் பண்ணாங்க. அதுக்கு அப்புறமா தே ஹவ் கன்ஸ்ட்ரக்டட் ஒன் டனல். ஸோ அதனால எந்த நீர்த்தேக்கங்களுக்கோ இல்லை அணைகளுக்கோ எந்த பாதிப்பும் ஏற்படல. நம்ம ரிசர்வாயர்லேருந்து வாட்டரும் ட்ரா பண்ண போகிறது இல்லை,
நிலத்தடி நீரையும் எடுக்க
நிலத்தடி நீருக்கும் இதுக்கும் சம்மந்தமும் இல்லை.
இந்த திட்டத்தை ஏன் பொட்டிப்புறத்தில் தான் செய்யணும், குஜராத்தில் செய்யக்கூடாதா?
குஜராத்தில் வந்து முதல்ல இந்த மாதிரி உயரமான மலைகள் கிடையாது. ரெண்டாவது, இந்த திட்டத்துக்கு தேவையானது வந்து ஒரு 1000 மீட்டர் கவர் இருக்கணும். அதாவது மலை உச்சியிலிருந்து சுரங்க நம்மளுடைய சோதனை கூடம் ஒரு 1000 மீட்டர் கீழே இருக்கணும். செகண்ட் கிரைட்டீரியா வந்து இந்த மாதிரி ஒரு ஆழமான இடத்துல சுரங்கம் தோன்றதுக்கு பாறைகள் வந்து அதிக சக்தி வாய்ந்தவங்க. இந்த தேர்ட் கிரைட்டீரியா வந்து என்னன்னா, இது நார்மலாக வந்து ஒரு லோ சைஸ்மிக் ஜோன் இந்த இந்தியா முழுவதும் ஒரு 5 பூகம்ப மண்டலங்களாக தீர்மானிச்சிருக்காங்க. அதில் வந்து ஜோன் 2 அதுதான் லோயஸ்ட். இந்த சைட் வந்து ஜோன் 2ல இருக்கு.
எவ்வளவு மக்களினுடைய விவசாய நிலத்தை நீங்கள் கையாளுறது?
ஒரு சென்ட் கூட விவசாய நிலையம் இது வந்து நிலம் கையகலப்படுத்தாதுன்னு நான்.
சரி, விவசாய நிலம்னா சாதாரண நிலம்?
சாதாரண நிலமும் அதை என்னென்ன இப்போ யூஸ் பண்ணிட்டு இருக்கிறாங்களோ அதை யூஸ் பண்ணிட்டு தான் இருக்க போகிறாங்க. அது
மலைக்கடியில் தான்
இருக்க போகுது, அதனால ஒன்றும் இல்லை.
நன்றி. ஐ திங்க் ஒரு பலவிதமான சந்தேகங்கள் மக்கள் மத்தியில் இருந்த பலவிதமான அச்சங்கள் போன்ற விஷயத்துக்கு பற்றிலாம் ஒரு புவியியல் நிபுணர் என்ற முறையில் உங்கள்கிட்ட நல்ல பதில் கிடைத்தது. ஒரு தெளிவு பிறக்கும் என்று நினைக்கிறேன். நன்றி, வணக்கம்.
நன்றி.
டாக்டர் லக்ஷ்மி எஸ் மோகன் was a PhD student as part of India-based Neutrino Observatory INO collaboration, and currently she is working with Indian Institute of Technology, Madras. We are going to ask her how, as a student, how being a part of this INO collaboration has benefited her. Keep watching.
I had a better understanding of what is happening physics-wise, and not only were we trained in simulations, but we were trained in the experimental aspect of it also. So when you do this kind of a training, you're not using your detector as a black box. So you actually know that. So suppose someone says that, okay, your energy resolution is this, energy resolution is that, or direction resolution is this. I actually know, okay, what is this, what is happening in the detector, what that person is actually meaning. It also helps people to move on to other fields of physics also. The most important thing is that this is the first time that we are doing such a large scale indigenously developed thing in India itself. But it's also important that if we can make a contribution as contribution to the world science, it is important that we make that contribution.
Thank you, Lakshmi, for your comments. I'm very happy to have 3 students who are part of the INO collaboration. They are doing their PhD programs under the India-based Neutrino Observatory project. Hi guys, can you introduce yourself?
I'm Neha.
I'm Apurva. I'm Prithviraj.
Neha, I mean, what role you think INO played in training you in physics?
Throughout my PhD life, I have worked with various detectors. To name a few, like scintillators, RPCs, and similarly with electronics for that. I was involved in the making of the detectors, then the electronics, and then analyzing the data. So through such a hands-on experience, I'm now confident enough to take up new challenges. When INO will be built, it will be one of the facilities in India where all the students of India can join hands to do physics. And also I would like to say that it will provide a better platform for all of us to do great stuff.
Thank you, Neha. That was a very interesting. Coming to Apurva. Apurva, why do you think a country like India needs such kind of a project?
I worked on simulation of detectors, and now I'm working to build a detector like ICAL, a prototype detector, which is a miniature detector in Madurai. As a part of the program, I get to work the detector building, This experience is not usually available to students who work in a small lab or small, so that is one of the reasons why INO collaboration is required to come, and more such collaborations should come up in India and establish such facilities. Also, for a detector like ICAL, which is a very huge detector, you need a lot of technologies and a huge number of detectors to be built. A lot of industries in India will be required to build those detectors, which will be again beneficiary to the economic of the country.
Thank you, Varva. Very, very interesting points. Now let us move to Mr. Petraj. Petraj, you studied in Madurai Kamaraj University, you were born nearby this area, you lived in Tamil Nadu, and you are now part of this India-based neutrino observatory project. I mean, you are doing your PhD, you are about to complete. What do you want to tell to the students of Tamil Nadu, particularly who are studying engineering and sciences?
INO மாதிரி பேசிக் சயின்ஸ் எக்ஸ்பெரிமெண்ட்டில் ஸ்க்ராட்ச்லேருந்தே ஒர்க் பண்ணுறதுனால என்னோட எங்களோட கான்ஃபிடென்ஸ் வந்து ஆட்டோமேட்டிக்காக இன்க்ரீஸ் ஆகுது. இந்த கான்ஃபிடென்ஸ் வந்து ஃபியூச்சரில் வந்து எந்த ஒரு எக்ஸ்பெரிமெண்ட்டை வந்து ஹேண்டில் பண்ணுறதுக்கான ஒரு தன்னம்பிக்கையை கொடுக்குது. இது தவிர INO இருக்கிறதுனால சுற்றி உள்ள காலேஜ் யூனிவர்சிட்டி ஸ்டூடெண்ட்ஸ் எல்லாம் இங்கே வந்து ப்ராஜெக்ட் பண்ணுறாங்க. அவங்களும் இந்த மாதிரி R&D ப்ராஜெக்டில் ஒர்க் பண்ணுறதுனால நிறைய எக்ஸ்பீரியன்ஸ் அவங்க கெயின் பண்ணிக்கிறாங்க. இந்த எக்ஸ்பீரியன்ஸ்னால அவங்க வந்து சயின்ஸில் எந்த ஒரு பாதையில் போகணும் அப்படிங்கிற ஒரு நாலேஜ் எக்கச்சக்கமாக கிடைக்குது. இதே தவிர ஸ்கூல் ஸ்டூடெண்ட்ஸ் INO லேப் வந்து விசிட் பண்ணும்போது அவங்க வந்து சயின்ஸை வந்து ரொம்ப ஒரு ஃபீல் பண்ணி அவங்க என்ஜாய் பண்ணி அவங்க கற்றுக்கிற முடியும். அப்போ INO எக்ஸ்பெரிமெண்ட்டுக்கு இன்ஜினியர்ஸோட ஹெல்ப் தேவைங்கிறதுனால தமிழ்நாட்டில் உள்ள இன்ஜினியரிங் காலேஜ் ஸ்டூடெண்ட்ஸ் நிறையா பேர் INO எக்ஸ்பெரிமெண்ட்டில் ஒர்க் பண்ணலாம். அதனால் அவங்களும் வேர்ல்டு லெவல் டெக்னாலஜி வந்து டெவலப் பண்ணலாம். இந்த டெக்னாலஜி ஃபியூச்சரில் சொசைட்டிக்கு கூட ட்ரான்ஸ்ஃபர் பண்ணலாம்.
Dear friends, the distinguished scientists have spoken. We have heard them carefully. They said INO is safe. Neutrinos are safe. Neutrinos are very interesting. They are being studied all over the world. INO will put Tamil Nadu and India on the world map of science. INO will boost technology and the economy of the Theni district and Tamil Nadu. INO is a world-class experiment and everyone will benefit from it. Dr. Balachandran, the distinguished geologist, has told us that INO is no danger to the environment and no danger to agriculture either during construction or later. He has had much experience with such matters. We can trust his judgment. We also heard from Lakshmi and the PhD students, Neha, Apurva and Petraj. They work on INO science. They emphasized the long-term benefits of training in science. They will grow into future leaders of Indian science. They deserve our support. We want them to stay in India and work for the benefit of our country. I am also a scientist. I was the director of the Kodaikanal Observatory until my retirement. Even though I am not connected in any way with INO, I want it to succeed. I am fascinated by the science INO will unfold. I am excited about the jobs and the prosperity it will bring to Theni district and Tamil Nadu, and the technical training and higher education INO will impart to generations of young people. I am convinced INO will do much good and no harm, and sooner we get started, the better. INO will benefit all of us in the Theni district, in Tamil Nadu and in India. We have discussed this very carefully and thoroughly. Now let us start the work of constructing INO. Thank you.